Humanity is currently engineering the most complex structures in history, billions of gates calculating our world at light speed. Yet, if you looked at them, you'd see nothing. They are entirely invisible to the naked eye. Nanotechnology has moved past the science fiction concepts of robots swimming in the bloodstream. Today, it exists as a commercial silicon graveyard currently sitting inside your smartphone. As this technology shrinks, it creates a strange industrial requirement. The smaller the components become, the larger the machines required to build them must be. This hyper-expensive industrial reality operates right now, requiring an absurd scale of manufacturing to exert control over the invisible. These are semiconductor fabs. They are sprawling complexes the size of major airports, housing tens of thousands of workers and consuming enough electricity to power small cities. Inside, the environment is sterile and bathed in yellow light to prevent ultraviolet rays from ruining the materials. It is a hostile environment where these microscopic structures are forged. A single extreme ultraviolet lithography machine, the device that prints these chips, weighs over 200 tons. Each one costs roughly $200 million. We construct these cathedral-sized industrial environments to manipulate matter at scales roughly 1/10,000th the width of a human hair. Down at the nanoscale, the everyday world becomes intensely dangerous. Take a single speck of ordinary dust. To us, it's nothing. But on a circuit grid where wires are only 2 nanometers wide, that speck of dust acts like a nuclear bomb. If it lands on the silicon, it destroys the entire structure instantly. The human body sheds millions of dead skin cells and particles every hour. Workers must wear protective gear simply to prevent their own biology from destroying the product. We treat standard electronics manufacturing like a biological hazard zone because the physics of this scale are entirely unforgiving. Zooming past the cleanroom and circuit boards, we are left with the raw grain of the silicon surface. As we push toward the 2 nanometer node, we encounter the ultimate physical roadblock, quantum tunneling. In classical physics, wires act like pipes, but at 2 nanometers, the walls are so thin that electrons begin passing straight through solid barriers like ghosts. This leakage generates uncontrollable heat. The chip loses its ability to distinguish a signal, leading to catastrophic failure. Every design choice at this scale is a battle against the fundamental breakdown of the laws that govern the visible world. Building-sized machines successfully force electrons back into their pathways by carving deep, 3-dimensional trenches into the silicon, defying the chaos of quantum mechanics. The global economy and your everyday devices rely entirely on winning this atomic-level fight. Nanotechnology is an act of human defiance, a daily, frantically expensive attempt to tame the quantum realm to keep civilization running. We are rapidly running out of physical space to shrink, approaching the absolute limit of the 1 nanometer scale. We have to ask what happens to human progress when we can no longer build any smaller. Human exploration has found a terminal edge in the dark, invisible void at the end of a silicon wafer.